All right, so this is going to be day 2 on equation solving. We are not going to talk about U substitution yet. We'll do that on Monday. So you will not be able to do worksheet 4B this weekend, but anything else for the homework check, you will be good to go, okay? Everybody have out worksheet 4A? All right, it starts out with some review from yesterday. Anybody have a suggestion or want to come up to the board and do this one? Take a cosine out. What will it say then, Journey? Good job. Then what? Yep, we can play the take your turn being equal to 0 game, right? Cosine of x equals 0, sine of x minus 3 equals 0, or sine equals 3. Now, at this point, it's a good idea to look at the directions. Probably would have been a good idea before we started, but solve each question for all values. So we need all as in some plus or minus something, right? Because we have to have infinite values. Okay. So using our unit circle or our brain, where's the cosine 0? X is 0 at pi over 2 and at 3 pi over 2. And those repeat every 2 pi. Anybody know how to write that shorter? Okay, if you wanted the shorter version of that one, you could say this, okay, because they're straight across from each other. What about where the sign hits 3? Doesn't ever hit 3, it only goes between -1 and 1, so we're good. The ratio, if you think back to the definition of sine as a leg, opposite leg over hypotenuse, the hypotenuse is always the longest side, so that ratio will always be less than 1. Does that make sense now? I want to explain it that way. The radius of the circle doesn't matter once you take the leg divided by the hypotenuse. It would still be less than 1. All right. This is question 2. We did one like this on the notes yesterday, I think. Anybody see a trade we could make? Cosine squared plus 1 is sine. Is that true? It'd have to be minus, right? 1 minus. We don't have a minus anywhere. We can, but I don't think that. Yes, we could, and we'd have cosine to the 4th. Da 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 da. Okay, the suggestion was replace cosine squared with 1 minus sine squared. Why is that good?
Because then we have the same.
Yeah, we only have sine left, right? We still have a squared, but we might be able to factor or take out or something depending what happens now. The 1 plus the 1 are on the same side, right? So we have negative sine squared x plus sine x plus 2 equals 0. You know Hofbauer hates to factor anything when it has a negative a value, so I'm moving it all over to the other side. You can do it however you want. What do you think? I think we need a minus 2 and a plus 1, right? Because we need it to be negative 2 plus 1 is a negative 1 here in the middle. All right. Take your turn being equal to 0. Guys, when you talk, everyone around you has a problem hearing. So you're not just disturbing your learning, but everyone else's. If you set sine x minus 2 equal to 0, you will have the sine of x equals 2. Sine x plus 1 equals 0 would mean the sine of x equals negative 1. Now what? Doesn't ever happen. Where is the sine negative 1? Anywhere else? So what else? 7 pi over 2? What did you say? 7 pi over 4? The tangent is negative 1. Yep, you're okay. Because you weren't the only one thinking that. I heard a couple of people mumbling about that. We're looking for the sine to be negative 1, and the only place that happens is at 3 pi over 2. And then it's going to repeat every 2 pi, okay? If you pictured the sine graph, just to try to tie these together for you, okay, it only hits negative 1 once in a period, right? Because here's 2 pi. Hits it once right here, then another 3 pi or 2 pi later after 3 pi over 2, etc. All right, trying to make sure that makes sense to you. All right, there's another kind of question that we're going to try one of in a few minutes. You can just watch this explanation. Cosecant and cotangent, I don't have any squareds right now, but do those have a relationship? If we had a cotangent squared plus 1, we'd have a cosecant squared. Everybody okay with that? Pythagorean. So we're going to end up needing to square both sides here. If we move this over here, we'd have cosecant of x equals 1 plus cotangent squared. No, we just have 1 plus cotangent. I'm just making things up now. All right, then we'd square both sides. What would the left-hand side become? Cosecant squared, which we're probably going to have to trade. But be careful. What over here, 1 plus cotangent times 1 plus cotangent actually gives us 2 cotangent plus cotangent squared. Right? I don't want cosecants and cotangents. Can we trade now? In the beginning we couldn't because they didn't have any squareds, but what could we trade that for now? Okay, it says on my sheet cotangent squared plus 1. Then what? Some nice stuff happens. If I subtract a 1 off each side, that's gone, right? Subtract a cotangent squared off each side. No more of those. What's left on the left? On the right, I have 2 cotangent. On the left, I have nothing. 0. The only way that's true is if what? The cotangent 0? We divide both sides by 2 if that'll make you feel better, but I'm looking for where the cotangent is 0. All right, we don't look around our unit circle for cotangents very often, but cotangent is defined as cosine over sine, which means we're looking for an x value over a y value. What would have to be 0 for that to come out 0? X. So I'm looking for anywhere that has an x that's a 0 for the cotangent to be 0. Okay. We came up with these 2 solutions. And when I print these notes for someone, they're going to make no sense. Let's see if I can drag that down here somewhere. All right. The issue becomes that when you square both sides, you frequently get a solution that doesn't work. What was the original, guys? Somebody remind me what the original sentence said. Cosecant minus cotangent?
Yeah.
Okay. Cosecant minus cotangent equals 1. If I put a pi over 2 in, or this is a great chance to review these because it keeps showing up on quizzes and students aren't doing it right. Okay, cosecant at pi over 2. I go to pi over 2 on my unit circle. I find the sine value, and I do the reciprocal of just that number, and I get what? 1. Cotangent pi over 2. I go to pi over 2, and I do x over y, and I get 0. Is that true? That one works. Okay, go to 3 pi over 2. Find the sine value and do the reciprocal of that. Just 1 over that y value. Okay, minus the cotangent there, which is x over y. Is that working? -1 minus 0 is 1. That one doesn't work. Do you remember how I also suggested you could check these? Yes, sometimes if there's asymptotes, you can figure that out. This one would have hurt my head trying to do that way. You can graph them. Somebody said you can graph this and check your solutions, right? If you put cosecant x minus cotangent x, which would be a pain to type, 1 over sine of x minus 1 over tangent of x equal, and then see where it equals 1, you could check if those both made it equal to 1 or not. All right, we are going to do some checking by graphing eventually. Here we go. All right, guys, what do you want to try on this one? By the way, I might want to read the directions. It says 0 to 2 pi. When you do page 331, the book assignment, the book, and you'll see on an example I have here somewhere maybe. Was it on the one I just did? Was this one? Look, guys. Do you notice how the book types that? 0 to 2 pi with a hard bracket on both. But yet the answers in the back don't. So I don't know where's the typo is, okay? If you had told me 0 was an answer and included 2 pi because of the hard bracket, I would have said that's fine. The back of the book would only have 0. Just telling you now. I don't know why they... My quiz will have a soft bracket there, so... All right, but back to this question. We only need the answers on the unit circle. I have a tangent squared and a -1, but I don't think tangent squared minus 1 is equal to anything. Secant squared I don't have. Okay, so tangent squared would be what? Plus 1? Minus 1. So then if I do some simplifying, I have secant squared of x plus a secant of x minus 2 equals 0. How does that factor? That's a funky parenthesis, sorry. Positive 2 and -1 to get a positive 1 in the middle. All right, so the secant of x equals -2, or the secant of x equals 1. Again, I generally don't go shopping for a secant on my unit circle, right? But what is the definition of secant? 1 over cosine equals -2. What does that mean cosine has to equal? 1/2, right? The only way that's true, just flip them both over. The cosine is -1/2. That's what, does it make, think about that a minute. Does the cosine being -1/2 would make the secant Negative 2? All right. The other one is secant is 1, which means 1 over the cosine is 1, which means the cosine has to be 1. So I'm looking for those places. All right, where do I get the cosine is negative 1/2? Cosine negative 1/2, 4 pi over 3 and 2 pi over 3. And the cosine is 1. And if it was the book and it had a hard bracket on 2 pi, we could also call that 2 pi. But we're just going to go with those 3 solutions. Now, you could test them all. Tangent, the original function had some tangent stuff in it. Tangent does have asymptotes, so you might want to worry about it. Actually, secant does as well. I think these all work. The original one, was tangent squared. I'm going to put it just like that without an extra parentheses because I want to see if it works. I think that's how the book does it, or the manufacturers have allowed you to do that now. Plus 1 divided by cosine minus 1. If I set my window 0 to 2 pi, I'm hoping to see 3 places that it hits 0. 4 if you count 2 pi, right? So I'm thinking 0 works, 2 pi over 3, 4 pi over 3, and 2 pi. Just to test, I could do trace 2 pi over 3, and it should jump to one of those zeros. And it does. We good? All right, so it looked like all 3 worked. What about this one? This is problem number 4, okay? This gets in the way when we start doing the problem. We got people all confused last period. Crickets? Crickets? No ideas? Yes.
Oh, really?
Yes. I'm going to have to square both sides because there are no trades for plain old sine or cosine. Because you won't get exact solutions. You get decimals. And when you get to calculus, these kind of questions could be on the no calculator part. And you have to have the unit circle memorized by then. Yes, big. In part of the AP test is no calculator, and therefore a lot of calc tests have a no calculator part and a calculator part. All right, what is 1 plus cosine times 1 plus cosine? Good job. And the right-hand side, when I square the square root of 3, I just get 3. Square the sine of x, and I get sine squared. Had several people today suggest that we could do something with the cosine squared and the sine squared because that's 1. But unfortunately, it would be minus 2 or minus 3 sine squared if we moved it over here. It's just not going to work. But we do need to get everything in terms of the same function. No ideas? Ben, you got us this far. Okay, but a 3 sine squared minus 1 isn't going to get us a trade. A sine squared minus 1 would get us a trade. But we got that 3 there. What? We need to replace this with what? Okay, so this side will become 3 times 1 minus, whoops, I don't know where I'm distributing half of it. Which one I distribute will give me all right. Can you do some algebra? Add some like terms. Still going to have squared, so therefore you want to get it equal to 0 so you can factor. Add the 3 cosine squareds over here, so we'll have what? 4 cosine squareds. There's 2 cosine x. Minus 2. Now what? We could take out a 2. What can we do with that 2? Can 2 ever equal 0? We could divide everything by, just divide out the 2. It's gone. Now what? Yeah, I always have to write it out. Okay, 2 cosine times cosine is 2 cosine squared. 1 times 1, I need it to be a negative 1. But I need a plus. I think I need a here so that when I multiply, I'll get a plus 2 cosine. Does that work? Minus 1. All right, so the take your turn being equal to 0 game gives us cosine of x equals 1/2 or negative 1. All right, where's the cosine 1/2? And where is the cosine negative 1? Pi? Plain old pi? All right, this is a really easy one to type in and check by graphing if we have any extra solutions. I'm going to put them in y1 and y2. 1 plus cosine of x and square root of 3 times sine of x. And I want to see where they intersect and how many times. How many solutions does it look like we should have? 1 intersection point there and 1 there. Which one do you think we might be able to throw out? If this is 0 to 2 pi, it looks like the furthest over they intersect is at pi, right? And this one is past there. All right, if I clear the ink off this. And I test, go trace 5 pi over 3. I get 1.5, or if I'm on the other one, I get negative 1.5. They're definitely not equal at that point, okay? Are we okay? So that was the square both sides again. We're going to do these by graphing because nowhere in my unit circle is there a negative 7.29. All right, I'm going to talk about how to do this without graphing, but it's easier if I just do it by graphing first because that's the way most of you are going to do it. Go ahead and type sine x in y1 and negative 0.729 in y2. Set your window to 0 to 2 pi and find the intersection points. That's all there is to it. What mode should we be in? Good job. We're going to be in radians. Again, whoop. Okay. Your window window, you can do a zoom trig and then reset it to negative 0 to 2 pi. Most of the time it sets the y values negative 4 to 4. As long as I only have 0 to 2 pi, I only see how many solutions? 2. It's pretty hard to see if you're not doing it on your own calculator. It does say to go to a bunch of decimal places. Your calculator will sometimes also freak out if you don't get pretty close to the right value before you tell it to guess or to calculate. Is it 8, 5 maybe? I don't know. If I round to 4 places.
4.0105.
Me too. I got 3.9585 and 5.4663. Do you have it typed in as negative 0.729? Be careful. One time, somebody earlier today had 0.792, transposed some numbers or something. Are you in radian?
I don't know why it just did that. It freaked out at me. Yeah, I redid it.
Now you got this? Okay. Make sure, also, always guys, make sure it says intersection or you haven't hit enter enough times and you might still be on guess. All right. That's it for this answer, right? Now, I just want to talk briefly about how you would do that without a graphing calculator. If you just had a scientific calculator, you would have had to go to the home screen and type, look at the original equation here, sine is negative 0.729. So you'd go second sine negative 0.729, because even a scientific calculator has a sine button, right? And it actually finds this value, negative 0.8169. I want to talk about how old people like me had to do this problem at one point, okay? Here's the sine graph. The calculator told me that it crossed negative 0.729 over here at this value. That's this x value right here, right? Everybody see what I'm talking about? That means this distance right here is a distance of 0.8169. Any ideas how I could find this point and this point then? What's this value right here? That's pi. This little red line is the same value here, yes? So I could have said pi plus 0.8169. Try that. Type that in your screen, your home screen. Pi plus 0.8169. Do you get the 3.951? Okay. All right, the other one over here, to find that answer, I could just add 2 pi, but I could also have said 2 pi that same distance back right there. So type 2 pi minus 0.8169, and you would have got the 5.4663 number. Okay, so I had to use the symmetry of the graph to try to figure out the right answers. All right. You don't have to. You can type these in, get this answer, you're done. And what are you going to do for this answer? The exact same thing and say it repeats every 2 pi. All right, you could have also said, instead of this one, you could have said negative 0.8169 instead of that one, because that plus 2 pi is this, okay? So whether you found the closest two to the origin or the first two positive ones wouldn't have mattered. All right, 2 more quick questions, and we're done for the day. Number 7 is shearly graphing, If you look at this, there are no trades for cosine 3x or sine 4x. This is just crazy business. But it is really fun to see this graph, okay? And this part, guys, just means find the decimal answers between 0 and 2 pi, okay? It's not about 3 decimal places. Type this all in and see what crazy thing happens. 2 cosine of x. Oh, thank you. Cosine of 3x. Thank you for not letting me type the whole thing in wrong. Minus 3 sine 4x. All right, and then I'm going to go ahead and put the line y equals 3 in a different one. I don't know that I need to change my window. It'll probably go up off the top and bottom. I don't know. Just a tiny bit. Pretty fun graph, huh? It actually does repeat. If you go out further, we've pretty much covered a cycle. It starts over again fairly soon after this, okay? You can set your window, your X window, like 0 to 20, and you'll see it repeat a couple times. But for purposes of this question, we need how many solutions? I think it crossed 4 times in this window, didn't it? And this is another one where your calculator kind of freaks out if you're not pretty close to where you're looking for your answer. I got 4.0315. Anybody else find any of the rest of them? $4.5328. Anybody? No? Yes? Maybe? Is anybody else doing this question? $5.7954. And the last one?
Sam, what are you thinking?
All right. I agree with Cassie and the 2 other people who actually did the problem. Are we good? All right, last one. Is this never?
Yeah.
It is a tangent graph. Does the tangent graph hit 6? The range is negative infinity to infinity, right? You can graph this. Do I have to graph this? What did I talk about as the other way to find?
Guess and check.
Yeah, just go second tangent on the home screen, which I'm not on the home screen. On the home screen, do second tangent 6. Isn't it positive 6?
Negative.
No.
1.4056. If I graph, some of the older calculators don't show some of these very well. I think it'll go as high as 6 though pretty well. Tangent of x equals 6. Make sure my window goes up past 6. The tangent actually goes infinitely high, but the graph stops eventually. So if we had said, where's the tangent, like 30, it would find it as an intersection point, but it would look like it didn't intersect, which is kind of weird for students. Why don't I need to find two solutions? There's two in that window.
But that's after like a 2 pi. And it's
What's the period of tangent? Pi. So the next answer is exactly pi over. All right, so we're going to go plus or minus pi and call it good because we know it's going to repeat every pi. All right, one more time. The quiz on Tuesday. You need to have done the book assignment on page 331. And I would suggest you've done worksheet 5 by then. But you do not need to know the U substitutions that are on worksheet 4B, which are at the bottom of this that we're going to wait and talk about on Monday. That is not on the quiz, okay? The homework check will be Wednesday because on Monday I'm going to talk about U substitutions, so you'll be able to get that done by Wednesday. But for the quiz, so I'm going to give you like extra day to work, okay? All right, so I'm going to